everyone, we're going to find the limit as x approaches 0 of 1 minus cosine of 2x divided by 2 sine squared of x. Alright, so what we're going to do first is go ahead and write this down, and we're going to make it look like one of these here, because we know the limit of these by is 1. So if I can make it look like this, then it's going to be a lot easier. If you substitute in 0 in here, it's going to be undefined. So let's rewrite this as the limit as x approaches 0. I'm going to copy down 1 minus cosine of 2x, and we're going to fix this denominator. So I'm going to take 2 sine squared of x and multiply this by 1. In our case, it's going to be x squared divided by x squared. Alright, so I'm going to go ahead and put the x squared under here and do that. Alright, now if you notice this is all multiplying. So I can take this x squared and move it up here. So now I'm going to write it as the limit as x approaches 0 of x squared times 1 minus cosine of 2x, like that. Now for my denominator, I'm going to have, this is my denominator right here. So what I'm going to do is right under here, I'm going to write this is sine squared of x for this piece. Under here, I'm going to multiply this by 2x squared. So I just rearranged everything by moving this up here. Now I'm going to split it up and write this as the limit as x approaches 0 of this piece, x squared divided by sine squared of x, times the limit as x approaches 0 of this piece, which is going to be 1 minus cosine of 2x divided by 2x squared. Alright, well this piece here just equals 1. So this one is this one right here. I'll do it big like that. So that's because we could just let x squared equal theta. And this is x squared here. So this is going to be 1 times this. And now this part I can rewrite as the limit as x approaches 0. And what I'm going to do is multiply the numerator by the conjugate. So that's going to be 1 minus cosine of 2x times 1 plus cosine of 2x. So I also have to multiply the denominator by that. So we have 2x squared times 1 plus cosine of 2x. This piece here is just going to be 1 minus cosine squared of 2x. So let's do that. We have the limit as x approaches 0, 1 minus cosine squared of 2x divided by 2x squared times 1 plus cosine of 2x. Alright, now the numerator here, that's just going to equal sine squared of 2x using your Pythagorean identities. So just substitute that in. So this is going to be sine squared of 2x divided by 2x squared times 1 plus cosine of 2x. Alright, from here, this is a long one. From here, I can write this. I'm going to take this piece out here and write this as the limit as x approaches 0 of sine squared of 2x divided by 2x squared times the limit as x approaches 0 of 1 divided by this piece, 1 plus cosine of 2x. All right, so I'm going to do this limit first. So this limit here, if you substitute in 0, you're going to get 1 divided by 1 plus 1, which is 1/2. So now we have the limit as x approaches 0 of sine squared of 2x divided by 2x squared times 1/2, because this piece here was 1/2. All right, so I'm going to go ahead and multiply this 1/2 times 2. You get the limit as x approaches 0 of sine squared of 2x divided by 4x squared. All right, this can be written, and I'm going to do it on the next slide, this can be written as 2x squared. So let's do that. We're going to have the limit as x approaches 0 of sine squared of 2x divided by 2x squared. All right, since these are both squares, I can now write it as the limit as x approaches 0 of sine of 2x divided by 2x squared. Now, from there you can kind of see this just going to equal 1, or you can say let t equal 2x and then substitute that in. So you would get, also if t equals 2x, then as x approaches 0, t will also approach 0. You just substitute in the 0 there. So this is going to be, we can write this as the limit as t approaches 0 of sine of t divided by t, and then square it like that. And this is going to equal 1 squared, which equals 1. So your limit is 1. Thank you. Have a nice day. Bye-bye.